Okay, Assalamu alaikum, Shabab. Welcome back. I hope you are ready for today's quiz. The quiz will be given to you at the end of the lecture. So we'll continue our discussion, and then we'll allow you to start the quiz. Okay. So, but just to let you know, to get ready for it, the quiz, ya Shabab, is going to be a whole procedure, but one final answer. The question is asking about one final answer. You will be provided with a space at the end to provide the numerical value. And after we end the quiz, okay, I am going to, within 1 minute, just exactly after I end the quiz availability, I will open a submission link for the quiz solution. Do you understand? So please, yes. Yes. What?
تقدر تفتح سبمشن حق نرفع اللي هو الرسم البيبر صح؟
The solution.
Yes. كم مدته؟
Well, I will not give you more than 5 minutes to upload the image. It's supposed to be one page, ya Shabab. Take a picture and upload it. Not more than 5 minutes. Okay.
دكتور.
So yes.
معلش دكتور، بس هل بيكون نفس الكويز الماضي إذا كانت إجابة صحيحة ما يحتاج أسوي سبمت ولا لازم أسوي سبمت في الحالتين؟
How do you know if it is correct ولا لا؟
لأنه كان يصحح لنا في الكويز الماضي، كان يعطينا الدرجة.
The purpose of the final answer is definitely to make it easy for me. Okay?
Okay.
If as far as I know that يعني عشان الطلاب اللي حلهم صحيح أنا ما أضطر إني أروح يعني I will check the solution but I don't need to grade it. But من المفترض إنه الكويز ما راح يعلمك. You will not know. If this happened before, maybe it was by mistake. But the question, you should not know if you got the right answer or not until the availability end, until I end the availability. So you will never know. So you better take the picture, make it ready, and then when I end the availability, you will have 5 minutes. Now, if you during the 5 minutes, if you know that your answer is correct and you don't want to submit the solution, it's up to you. I'm not gonna grade it. But if there is any mistake or something, this is why I need to see the solution. Okay.
Okay, thank you, Doctor.
Okay. Now, so in the last class, ya Shabab, we talked about this critical practical issue, which is very common in the industry around us. It's very common even in households, you know, and في المنازل وكذا. So what happened is we want to understand what is the strength of the bolt, basically, and how do we analyze the joint. So in order to do this, I just want to try to convince you with this concept. If last class we kind of, you know, discussed it at the end that between the head and the nut, everything is active there, logically. The bolt should be under tension because we stretched it. How is it stretched? Well, the head here cannot move because it is pushing against a metal or a hard material. And the nut, as you screw it, the bolt goes from the other side. So literally, you are pushing the bolt from the other side. And by pushing it up, you are stretching it. Now, the only question is this. When you stretch it, this is where the action happen, and then you have the clamping force. That's what happened. But what are we going to do? We will see that the health of the joint is basically composed of the strength of the bolt, as well as, we will see later, the stiffness of the joint itself. This joint, how stiff it is. So, forget about the joint stiffness. Let's talk about the bolt. So, for the bolt, we can understand that I told you that the bolt is being stretched. So, when the bolt is being stretched, we can simply say, okay, can I deal with the bolt as a spring? We use linear elastic analysis here. We never talked about something beyond plasticity. So the question is, if I assume that the bolt over here, this part, which is between the head and the nut, okay? If I assume it to be spring, then the logical thing is to say that this part is one spring and this part is another spring. صح ولا لا يا شباب? If we want to be accurate. Why? Because the stiffness will depend on the material here, which is for the shank, it's uniform, cylinder. For the threaded part, is different. Now the differences are little, but still, it is different. This is going to behave as a spring by itself, and this one is going to behave as a spring by itself. For that reason, we have two configurations. Two. The first one will teach us what are exactly the portions that are within the grip and outside the grip. What is important to us is how much is within the grip, how much. And you can imagine that this stiffness will change depending on how long is the shank, how long is the threaded part. So this configuration will be the standard configuration, a nut on the left hand side. On the right hand side, okay, there is another configuration, which is the configuration that consists of a bolt, a washer, a first plate, and the second one clamped together. Now, with the shabab, what happened? There is a thread in here itself. This one is threaded. And basically, when we screw, the same business happen. Okay? The thread, as you screw more, the bolt comes out from the other side, but it cannot rigidly move because the head cannot penetrate the material. And for that reason, the bolt is getting longer. The only question here is this. Do you remember when we told you that when you screw a bolt, there are certain number of threads which will take the load and then the remaining will not? This business will happen here. For that reason, there will be some relation that will teach us how much of this part is carrying the load. So we'll teach you how to deal with this. We'll teach you how to deal with that, okay? Now, remember, when we, ya shabab, when we do this, it's for the sake of knowing the standard. How are these dimensions? This is a small h. This is T2. This one is T1. And there is L capital T, there is L capital, there is LD, there is L small, and all of these numbers, we need to know them. Now, luckily, you don't have to remember anything, okay? Everything now will be discussed in the next slide. So what do we have here? Very simple figure. This figure is very long. It's like 1.5 pages in your textbook. But it's actually very straightforward. All what you need to do is that as an engineer, you need to appreciate the details of this. You don't just assume things. So what happened is this. It says here that given a fastener diameter, D, look at D over there, and look at D over there. That's the nominal diameter of the bolt. And a pitch in millimeter, okay? Or the number of the pitches in millimeter, or the number of thread per inch, which is capital N for inches system, okay? The washer thickness T can be obtained from table A32 and A33. What are those tables? Basically, they tells you that for certain bolt, the washer is this size, and you will know the detail. What is the thickness of the washer? What is the diameter of the washer, and so on. Don't worry, we will go to these one as we move on. Don't worry, they will not be strange. They will become like table A20 to find the yield strength and the ultimate strength. Don't worry about them. Now, then we have the nut thickness. How much is this capital H? Okay, this is very important. You may think that, why do I need to know it? But you will see. From where we get it from? Table A31. You go to table A31, and what are you going to see? You will see the sizes of the bolt. يجي يقول لك مثلا نفترض السايز اسمه, for example, the size is M12 is a metric 12. 12 means a diameter, the small diameter. You should use this nut. خلاص خلصنا. You cannot invent your own nut. You just use that. Do you understand? So, what is now important is this. We go to the grip length. Look at it. The grip length. Where is the grip length? Look, the name grip means everything between the head and the nut for this guy. And for this guy, it's a certain length where the gripping action is happening. Beyond it, we know that the threads beyond a certain length, they will not carry any load. So as if there is no gripping. Our intention always is to focus on this part where the gripping is happening. Do you understand? So if you look, this length is called small L. Small L. Now, where is the small L? Look at it. There. This is a small L. From the beginning here, all the way here. Now look interestingly, ya shabab. The grip length includes the washer. Now, in this configuration, we have only one washer, which is here in the back. If you have washer in the front, it will be included. Why? You might even have 1, 2, and then 3 blade, and then a washer, and then a washer. Everything is the grip. Everything. بما معناه يا شباب, everything which is squeezed in between the head of the bolt and the end of the nut. كل شيء مضغوط. طيب, what is that small length in configuration B? What is it? We said it is very difficult. There is no nut. صح ولا لا? So, it is as follows. Look at the equation. L small, look at it. You want to see L small? Start from here and end there. This is L small here. No nut. What is that measure? How much? It is small h. Where is a small h? This guy. What is this guy? It is the grip or the distance between the head and what? And the first blade. First blade, this guy, this one. This is the first blade. This is the second one, or if we call it the first member and the second member. Now, the first member might include with it the washer. If there is no washer, it's okay. You just have to go from the beginning all the way to the first blade. So that measure is H plus what? T2 over 2. What is T2? I know it's getting messy, but I'm going to clean it up for you over here. Look, T2 is actually the thickness of the second member. You see that? plus T2 over 2. This is if T2 is less than the diameter of the bolt. This. What if T2 is bigger than the diameter of the bolt? Well, you should use the other equation, which is H plus D over 2. Understood? Very simple if you know the number. But this is like superposition, ya shabab. You need to know exactly what are the numbers. And you need to understand it. So for example, here we have a washer. There is no washer, it's okay. You will calculate the distance from the head until the first member. This is H, small h, okay? Now, we go to the next one. The next one is the capital L. Capital L, if you look at it, it's actually the entire fastener length. عدل? And rounding using table A17. A17 is for the standard length. Now, this is capital L. It's the length of the entire screw. Now, this is very important because in some question, we will ask you to find the proper screw and you will, or fastener. And for that reason, you will actually design to find this capital L, okay? Now, for A, which is this one, this is A, this is B. So for A, the capital L is the length of the, look, there is no answer, no definite answer. Capital L must be greater than the small l plus what? Plus h. H is the head or the height of the nut. Why it is must be like this? Actually, يا شباب راح نعلمكم يعني we will teach you later that there is a standard for this distance. يعني شباب مو اللي تشوفوه, you see it here in the local community where people use a screw to clamp two things, and then you see the bolt like this, and there is a nut here. This is a joke. This is a joke. This is wrong. Do you know how many threads standard should be after the nut? Two threads. That's it. Only two. So,
for all cases, doctor.
شلون?
In general, two.
Yes. You should pick the bolt size such that when you grip the entire thing, you should not have more than 3 or 2 threads. That's it. We will talk about it. Don't worry about it. Okay? Now, so how much is that length depends on the pitch size, صح? So we'll talk about it later. For figure B, L capital is H, small h, plus 1.5D, which is what? 1.5 the diameter of the bolt. Why? The bolt might end here, ya shabab. It doesn't have to go all the way to the end. You have a thread, but it doesn't have to. You understand? This part could be threaded but the bolt has to be of that size, 1.5 the diameter. Okay. Now let's go to the threaded length. How much should the threaded length be? How much? It should be, this is what we talked about in the beginning, okay? We said that 4 inches. You remember this, Shabab? I don't need to talk about it. This is the same equation as here. This is it. It's the same. So I don't need to talk about it, just to save time. So this is exactly the same equation for metric and 4 inches. Now, we are reaching the end. So this is, why do we have this? Oh, I think I duplicated this. This shouldn't be here. There's no need. It's already in the previous slide, so we don't need this one. Okay. Now, let's look here at the, we are approaching near the end of the lecture in order to start the quiz. Now, this is very important information. After you find these lengths, okay? Look, the length of the unthreaded portion in the grip. The length of the unthreaded portion in the grip. What is that? It's basically this. How much? It is mathematically the entire length of the bolt minus the threaded part of the bolt. And we will know how much is this part. We call it the shank. Then, what is the length of the, sorry, that one is the unthreaded part. What is the length of the threaded part in the grip? لاحظ, the threaded part is all of this. But how much is it inside the grip? Only this one. Only this one is inside the grip. So, it is equal to L small t, which is equal to L minus LD. What is LD? اللي جاوبناه قبل شوية. This one. This is LD. This is the length of the unthreaded portion. Now, what is the area of the unthreaded part? What is the area of unthreaded part? The area of the unthreaded portion is equal to AD, which is this area, and it is pi over 4, what? D square. Pi over 4D square, that's the area of it. Very simple. What is the area of the threaded portion? The one which has a thread. ايش قلنا عنها يا شباب? This is AT. AT. We go and find it from table 8.1, 8.2. We told you AT is defined experimentally. We don't know it. We cannot measure it, you know. We have to do it experimentally. So that one, you go and get it from the table. Now, if you want now to find the stiffness of the bolt, what are you going to do? You will assume that the stiffness of the bolt is coming because you have two springs in series, okay? Two springs in series. One of them is for the threaded portion, so I will call it KD, stiffness for the portion that belong to D, the smooth part, and stiffness that belong to what? The threaded portion. Now, we know, ya shabab, that if I want to find the stiffness of the bolt now, okay, I basically 1 over KB, this is how we find it in series. 1 over KB will be equals to 1 over KD plus 1 over KT. Now, there is a relation of the stiffness, if you recall, okay? And if we find KB by multiplying the cross product and then taking the reciprocal, what are we gonna get? We're gonna get this equation. I want you to remember this equation very, very, very well. Very well. Because all of the scary story I told you about gases leaking out and killing people or harming them will depend on the stiffness of the bolt, which is KB, and the stiffness of the member, which is KM. What is the stiffness of the member? This is what are we going to do next class. I may introduce it to you in a minute. I will see if we have time. But in general, ya shabab, the stiffness of the bolt, KB, let me read the equation with you. It is AD, the area of the unthreaded portion, multiplied by AT, the area of the threaded portion, multiplied by the modulus of elasticity, which is what? Just if this is, most bolts are steel, so it is 210 gigapascal, divided by divided by, look, AD, the area of the unthreaded portion, multiplied by what? L small t. What is L small t? Is this one, which depends on L small d. L small d depend on capital L and capital LT. So you need to go backward to find all of these numbers. Do you understand? Just to find the stiffness. All of the long story, everything here would be necessary just to find L small t, and then plus AT, the area of the threaded portion, multiplied by LD, which is the length of the unthreaded part. So you will solve everything before. L, small LD, small LT, all of it, just for the sake of one purpose, to find the stiffness KB. خلصنا. Now, what is next is the stiffness of the member. What is the stiffness of the member? Well, in 1 minute, I'm gonna show you. We will, when we squeeze, ya shabab, when the members are like this, okay? So let's assume one of them is made from aluminum, one of them is made from steel, for example, okay? So this is steel and this is aluminum. Now, when you apply a pressure on them because of the gripping, okay? And because there is an external load applied to them, now, in order to analyze how the member, because ya shabab, part of the load, when the yellow load هذا, part of it will go to the member, or part of it will go to the bolt, right? The bolt and the member are under compression, okay? Actually, the bolt is under tension, the member is under compression. And each one of them now is like a spring. So even the member, you can imagine that this is a spring and this is another spring. But the difference here is that this spring is crushed and want to expand. So again, if we use the analogy of the spring, then we will use the stiffness. And because this is made from red, this is made from green, we can even put washer, which is made from yellow material, and then we put a third member, okay? We can put a third member, which is black, and a fourth member, and a third, and so on. That's why, what are we gonna do? We will deal with the stiffness, the resultant stiffness of the member, just like the bolt. The bolt has two springs. One represents the unthreaded part, one represents the threaded part. For the member, regardless how many things you are squeezing, 2 washer, 3 member, those are 5. 2 washers, 2 member, those are 4. No washer, only 2 members, there are 2. So 1 over K1, 1 over K2, 1 over K3 plus 1 over Ki. You find the stiffness of each one, you add them together, then you reverse it, and you find the stiffness of the member. Now, the last word I want to tell you is this. It may look like, wow, this is a lot of work. But if I told you that in order to find the yielding strength, the yielding factor of safety, for the joint, you will need KB and KM. In order to find the fatigue strength, you may have fatigue loading. You will need KB, KM. Then you will understand that finding KB and KM is actually the most important part of the whole process. Do you understand? For now, I am going to stop my webcam. I think